Chapter 2, Lesson 3 of Pre-Calculus, continuing to look at polynomial functions. And in the last video, we took a look at determining what's the maximum number of zeros that a polynomial could have. And remember, that matched the degree of the polynomial. And remember, the zeros are going to be where it crosses or touches the x-axis, or the maximum number of times that it can cross or touch the x-axis. We also looked at the maximum or minimum numbers of extrema that the polynomials could have. And remember, it can have one less than the highest degree. So we want to get a picture of these polynomials because we want to graph those, and so we're going to kind of piece these together. So we've talked about the number of max and mins it can have. We've talked about the number of zeros it can have. Now let's take a look at the ends of the polynomial. So we're going to look specifically at the end behavior. What's happening as the function approaches negative infinity? What happens as the function approaches positive infinity? And I want us to look at this demonstration that I have to kind of give us a picture, or to help us kind of see maybe what's happening as we go on. So as we look at this function here, I want you to notice up here we have the equation, and notice that the leading term is an even power, so it's a squared function. Now I want you to pay attention to what happens to the ends of the function. Out here as positive infinity, this is going up to positive infinity, and here as you're approaching negative infinity, you're going up to negative infinity. I want you to notice what happens as we change the value of each one of these terms. Okay, so here's a positive quadratic. This first value is positive, and I want you to notice what happens as I change the constant. What happens to these ends? So both are going towards positive infinity. What happens when I change the constant? And you'll notice that even though I'm going from negative 100 to positive 100, it's not changing the end behavior at all. Both end behaviors are still pointing or going towards positive infinity. What happens if I change this linear term? Does that change direction of these end behaviors? And again, you'll notice that no matter how far I go from negative infinity or negative 100 to positive 100, that the end behaviors continue to point up towards positive infinity. All right. Now watch what happens when I change the coefficient of the leading term. What happens here? So if I go up to positive infinity, nothing changes. But now when I go, notice that it went to negative. What happened to the end behaviors? Now they're going towards negative infinity. Okay, positive and then negative. So as I change the coefficient of the leading term, it changes the end behavior from going up to down. Now let's go ahead and add another positive or a even power. So here we're at our largest one is a fourth. Okay, again, notice that these are going up to positive infinity on both. Again, I want you to notice as I change the constant, the end behaviors don't change. As I change the linear term, the end behavior doesn't change. Now remember in the last one, when I changed this term, it changed, but notice as I change the squared term, the end behaviors don't change. Now what happens if I change the leading term? Okay, nothing if I go to positive, but when I go to negative, it reflects them over. So a negative leading term, when it's even, changes it to both going towards negative infinity. So you'll notice that if the leading term is a even power, whether it was a squared or fourth, if it's positive, the end behaviors both go towards positive infinity. If the leading coefficient is odd, both end behaviors go towards negative infinity. So keep that in mind, and we'll kind of wrap this up or kind of summarize it when we get finished here. Well, let's look at a leading term where the leading term is odd. Okay, so the leading term is just odd. So let's go ahead and do that. Okay, so we're going to change, now we're going odd. So this is a first degree, it's a linear, and I want you to notice what happens as I change the constant. And again, we're only looking at the end behavior. So with an odd end behavior, or with an odd leading coefficient, notice that you go towards negative infinity. This end behavior is going towards negative infinity. As you go to positive, it's going to positive. So again, if I change the constant, does it change the end behavior? No. You still have negative infinity as you go towards negative x values, and positive infinity as you go to positive x values. Now again, what happens if I change the leading coefficient from a positive to a negative? Notice it reflects it over. This was going to negative infinity, now it's going to positive. This was going to positive infinity, now it's going towards negative. So again, as I change the constant, that doesn't change the end behavior, but if I change the coefficient of the leading term, it does affect the end behavior. Okay, let's add a higher power odd. So let's go to a cube. All right, so now I have a cube root, or a cube function, excuse me. Now watch what happens when I change the constant. Again, the end behavior is going towards negative infinity for negative x values and going towards positive infinity for positive x values. Notice as I change the constant, those end behaviors don't change. As I change the linear term, those end behaviors don't change, even though that was changing them before. Now, as I change the leading term from positive, whoops, that's a squared. Even if I put a squared in there, you'll notice that the leading one is a cube, so this doesn't change. Now, what happens if I change the leading coefficient from positive to negative? Well, notice it reflects it as I go to negative. So no longer, again, are we going towards negative infinity as we have negative x values. We're now going to positive. As we go to positive, we're now going to negative infinity. So it's only as I change the leading coefficient does that change the end behavior. Again, if I put a 5th degree polynomial in here, let's make it positive, and I go ahead and add a fourth root or fourth term, x to the fourth term, again, you'll notice no matter how many times I change the constant, the linear term, the quadratic term, the cubic term, even the fourth term, none of those change the end behavior. It's only when I change the leading coefficient from positive to negative are the end behaviors changed. Okay? So I hope that little demonstration gives us an idea of what can happen or what controls the end behavior of these polynomial functions. All right? So as we look at that demonstration then, it's the leading term that determines the end behavior of the polynomial. Okay, those other terms don't affect anything at all. And again, how many possible end behaviors were there as we looked at those? There were 2 possible end behaviors if the leading term was a even power, and there were 2 other possibilities if the leading term was odd power. So we actually only have 4 possible end behaviors for these polynomial graphs. All right, and this will kind of summarize what those 4 possible end behaviors are. So let's look at those 4 possible end behaviors. So if the leading term is an odd exponent, remember those are the lines, cubics, fifth, or whatever. Remember, when the leading term was positive, the end behavior for negative x values was going towards negative infinity, and the end behavior for x values going to positive infinity was positive. So the only possible end behaviors for odd power leading terms are either negative infinity and positive infinity if you're going left and right, or if they remember that leading term became negative, then it reflected those over, so then you were going towards positive infinity as you went to negative, and going towards negative infinity as you went to positive. These are the only 2 possible end behaviors, completely determined by 2 things: if it's odd power and if the leading coefficient is positive or negative. If we're looking at quartics or even powers, then we had these possibilities. Remember when it was a squared or a fourth, or those are the only 2 examples we had, both end behaviors were going towards positive infinity if the leading coefficient was positive. If the leading coefficient was negative, both end behaviors were going towards negative infinity. So these are the only 4 possibilities for end behavior when we're talking about these polynomial functions. Okay? So to kind of summarize what we've looked at so far for polynomial functions in the first 2 videos, we looked at the possible number of extrema, and that's 1 less than the degree of the polynomial. We looked at the possible number of zeros, or the possible number of places that could cross or touch the x-axis, and that is equal to the number of the degree. We now know what the end behavior is going to look like and what determines that. That's going to be the leading term determines what the end behavior is, whether it's odd or even, and then whether it's negative, positive is going to reflect that over, so you end up with 4 possible end behaviors. Okay, so we're kind of getting a picture of what these graphs look like. In the next video, we'll look at the zeros, and we'll probably spend a couple of videos possibly looking at those, and then we're going to put all of those things together and sketch these polynomial functions just from looking at the equations when we finish up.